Alright, our previous lessons in transformations, so we dealt with translations and stretches. So today we're going to do our final type of transformation, and that's a reflection. So when you look at this graph, it looks like the bottom graph, you can see this one here, looks like it's been reflected up and down compared to the original. So we're going to go through similar terminology. We're going to deal with horizontal and vertical separately. So we'll start with our vertical. So you can see that when we have a vertical reflection, the entire graph gets flipped upside down. So one thing we got to be careful of, first of all, is our notation. So when we're dealing with vertical, we put a minus sign where our A value would be in the equation, which makes sense. Remember, our A value is a vertical stretch. So now if we have a negative there, it would mean it's a vertical reflection. And when we flip things up and down, you can kind of see this coordinate here gets translated down to the -1. So we're going from +1 down to -1. So our mapping, the only thing that's changing is our y coordinates are changing signs. And the last thing to be careful of with reflections is watch for the wording. Often they'll say something like a vertical reflection across the x-axis. So this is our x-axis, so that's what we're reflecting against. And we'll always go across the x-axis with vertical reflections. It won't be around any other line or any other point. So we'll say vertical reflection across the x-axis, or it could say about the x-axis, or over the x-axis, or in the x-axis. Anything like that is all the same. Or sometimes they even say across the y equals 0 line, right? So if we were to graph y equals 0 on our calculator, it would be a horizontal line right along the x-axis. And that's it. So you can see vertical is pretty simple, just a negative out front. And you can see on the equation, you can see our original equation is y equals x squared. Our new one just has a negative out front, so negative x squared would give us that vertical reflection. So horizontal works pretty much the same, except we're going to flip it horizontally, so the negative now is going to be where our b value is. So inside the brackets, where the x value is, that's where we'll have our negative on the equation. So for our first equation, whatever it would be, you can see this one is f of x. Our horizontal reflection now is f of negative x. And our mapping, because we're going horizontally, it's our x coordinate that's switching signs. And because we're reflecting vertically, our line of reflection now is the y-axis. So we're going sideways across the y-axis, and again, we could use about the y-axis, over the y-axis, or again, we could say in the x equals 0 line. Right? If we tried to graph x equals 0, that would be a vertical line right along the y-axis. And again, horizontal is only going to be across the y-axis. It won't be any other line. So if I gave you an equation, let me just suppose we did a quadratic. So let's suppose we have the regular quadratic y equals x squared. If we do a horizontal reflection, we would just put a negative on where the x is. So you can see mathematically that equation would stay exactly the same, which kind of makes sense. We'll go back to the previous graph. Right? Our original is y equals x squared, so if we were to actually do a horizontal reflection, you can see our graph would just, this half would reflect to there and vice versa. So our graph doesn't change, and that's why our equation doesn't change, and it's because of this negative squared, the equation would stay exactly the same. So when you're working with equations, basically the negative out front for vertical, negative inside where the b value is for horizontal. Today we're going to do one other type, and this is different than what we've looked at so far, and it's when we do diagonal reflections. So diagonal reflection, if we look at this picture, you can see we're reflecting the original graph across this dotted line that goes through the grid diagonally. But let's just look at a few coordinates. So on this graph we have a coordinate at 1, 0. You can see on our reflected graph it's now becoming 0, 1. So if we actually compare what's going on there, our coordinates are actually just flipping spots. You can see our x and y just trade locations, and that happens for every coordinate. So if I picked another one here at, this one's at 2, 1, you can see on the new graph it's now at 1, 2. And that works for every coordinate. Okay? So our reflection line is this diagonal, which is y equals x, just a regular straight diagonal line, and all we do is flip our x and y coordinates around. So our equation ends up being just a flip of the x and y as well. So if this original graph, let's just do something like y equals 3x plus 2. That was our original equation. Our diagonal reflection line, we could just write it as x equals 3y plus 2. And that would be a good way to describe the reflected graph. So let's go through a few examples. So the first one we have here is, it's saying y equals f of negative x. So that's going to be our horizontal reflection. And because it's horizontal, we're going to flip it across the y-axis. Okay, so remember then when horizontal, our x-coordinates become the opposite. So this first one we have negative 6, 6. That coordinate's going to become positive 6, 6. So let's draw that one over here. The one that's at negative 2, negative 2, it'll become positive 2, negative 2. So that's down there somewhere. Okay, so that's our first part of the graph. Let's keep going. 0 doesn't change, right? So that one ends up being the exact same point, or that's going to end up being our invariant point. And we can keep going with the rest. The next one will be negative 3, 1. So that's about there. And our last one would be at negative 5, 0. Which is about there. And that's it. So there's our horizontal reflection of this function. So let's do the same thing again, but this time you can see we have a negative out front. So this one will be our vertical reflection, and this is going to go across the x-axis this time. So if we reflect it vertically, you can see now our y-coordinates will be the opposite. We have negative 6, negative 6 for the first one. So this one that's way up here is now going to go down here somewhere. Negative 2 would be negative 2, positive 2. So it's going to go upwards. The next one that's at 0, negative 2 will now be 0, positive 2. So it's up there. Then we have 3, negative 1. So it's down there somewhere. And then our last one, 5, 0, would be the same. So again, you can see that would be our invariant point in this case. So if you kind of look at the two last graphs, the previous one, the horizontal translation, our invariant point was along the y-axis, which makes sense because that's where we're reflecting across. And in this new one, our invariant point is where it is on the x-axis, which makes sense because that's where we're reflecting across the x-axis as well. Okay. Before we move on, let's actually just look at the domain and range of these graphs as well. So our original function had a domain of negative 6 to 5. And it had a range of negative 2 up to 6. And if we compare that to our new graph, our new domain is still negative 6 to 5, which makes sense because we didn't change the x-coordinates, so they should be the same. But our range got flipped, so you can see our range now is going from negative 6 to positive 2. So if you kind of compare the range values, you can see our domain and range made sense. The domain stays the same, the range became the opposite when we flipped our signs. Okay, here's one more. So this one you can see now we've got our diagonal reflection, right? Our x and y are trading spots, and that would be a reflection in the y equals x line. So let me just sketch that out. We'll be a line something like that. So our xy coordinates will just trade spots. The xy will become yx. So if we flip our coordinates around, the negative 6, 6 becomes positive 6, negative 6. So it's going to be down here somewhere. The next one, negative 2, negative 2, both exactly the same. So that should be our invariant point in this case. Right, so any points that are along that diagonal line will be our new invariant points. Let's keep going. 0, negative 2 would be negative 2, 0. So it's up there. 3, 1 would be 1, 3. And 5, 0 would be 0, 5. So that would be our diagonal reflection of that graph. And again, if we were to do domain and range, we won't, but if we were to do domain and range, we're just flipping our x and y, so our entire domain and range should trade. Maybe let's write it out quick, because it's almost the same as the last one. So our original domain again was from negative 6 to 5. Original range was from negative 2 to 6. And then if we look at our new graph we did, you can see our domain on the new one goes from negative 2 to 6. And then the range goes from negative 6 up to positive 5. So you can see if we compare these, our domain and range are just sort of interchanging between the two, which makes sense. We're flipping our x and y coordinates. We should be flipping our domain and range as well. Okay, so here's now one where we're going to do both. We've got a combination. So we've got a stretch being combined with reflections. So if we look at this graph, you can see that the graph is being flipped across the y-axis. So that should be a horizontal reflection. And if we look at the size of the graph, or we compare coordinates, you can actually see we've done a stretch as well. So let's just kind of work with one coordinate. This first coordinate here is at negative 2, 5. Oh, sorry, we're going backwards. So this first one that was at 1, 5 is switching to negative 2, 5. The next one that's at 2, 5, you can see it's switching to negative 4, 5. And we can keep going. The one that's at 3, 2 is now at negative 6, 2. And the last one, 4, 3, is now at negative 8, 3. So if we just look at those, what's happening? Well, our x coordinate is doubling. Right? We're flipping our x coordinate, so that should be a 2 times horizontal stretch. And you can see that we flipped it to the other side, so that means we also did our horizontal reflections. That would make it negative. And that's it. So once we have our kind of stretches and our coordinates figured out what's going on, we should be able to write our equation. So our equation this time should be horizontal reflection, so we should have negative on the inside, and a horizontal stretch of 2, so we write that as half, and we're done. Okay, let's work all the equations. So remember when we had our equations, we had our a value up front, and our b value was inside. So when we're doing these, you want to put the negative either where the a is for vertical reflections, or on the inside for the horizontal reflections. So for this first equation, we got reflected across the x-axis. So that's going to be a vertical. So our equation should just have our negative out front. So once you put the negative out front, you can see that would be our equation. Just negative, put everything in brackets, and we can simplify that a little bit. Just get rid of the brackets. Let's just FOIL things out. So we get negative x squared plus 3. Okay. The next one you can see is reflected in the y-axis. So that's going to be a horizontal reflection. So for this one, put the negative value just with the x, just where the b value would be. So if you just put a negative x in brackets, that's the simplest way to solve that one. And then when we FOIL that one out, you can see our equation would be negative 4x plus 5. And in any of these cases, you can always graph the original, graph the new one, and you'll see that they are horizontal or vertical reflections. Okay, 2 more. This next one is horizontal, so we put a negative where the x is, so just put the negative in the brackets, and then we can simplify that to become absolute values of minus 2x minus 4. You don't need to change anything else. On our last one, you can see it's vertical, so let's just put a negative out front of everything. So that one would change to negative 3x squared plus 3x minus 2. And that's it. We're done with reflections.